Folks, welcome to my YouTube channel. Good day, folks. Welcome to my YouTube. Good day, folks. Welcome to my YouTube channel. This video, it's an introduction to the photoelectric effect, which is the grade 12 topic. But I'm gonna start a little bit with the background of light from the previous grade. Now, light is an electromagnetic wave. Speed of light in all colors of light. Light has different colors. So, the speed of light is 3 times 10 to the power 8 meters per second. That's the V, or it's the C, the speed of light, right? Now it says colors is associated with frequency. If we look at the white light, this is the white light, right? The white light has the 7 colors. We call it's Roy, G, Bev, right? So these colors, they have different frequencies. If you can see there, red has a lower frequency, orange has a bigger frequency, so the frequency is increasing as you're going that way. You can see even from the wave nature there. And if they have different frequencies, that means they have different energies, right? So the greater the frequency, the greater the energy. But if you look at these light, these colors here, color of light, they have different wavelength. The more the energy increase, the wavelength decreases. The wavelength is the distance between the successive points in phase there. Okay, let's continue. Because of all light travel at the same speed, the frequency is inversely proportional to the wavelength. Very important information at constant speed. So the frequency is inversely proportional to the wavelength. If a light has a bigger frequency, that means it has a lower wavelength, right? Same applies. The energy and the wavelength are inversely proportional. If a light has a smaller energy, that means it will have a bigger wavelength there, right? It says here red with a lower frequency, it will have a longer wavelength. So red is here, it will have a lower frequency and a longer wavelength. You can see its wavelength, it's longer. Blue, which has a higher energy than red, it will have a higher frequency but a shorter wavelength. So the frequency and the wavelength are inversely proportional. Monochromatic light is a light with a single wavelength. So like blue light is a monochromatic light with a single wavelength. So all these lights, they have single wavelength, which is they have individual wavelength. So we call that it's monochromatic light. There's what we call a photons. Photon is related to energy. Now it says because electromagnetic radiation undergoes interference, it is proof that it is a wave. So the interference and the diffraction of light proves that light behave as a wave, right? And electromagnetic wave can be also considered as a particle, right? We'll talk about later the duality nature of light, right, when we do the photoelectric effect. Now, electromagnetic particles are packets of energy, which is, we call them, it's quanta, or quanta means it's a singular, means quantum. Now the energy packets, we call them photons. Guys, when we talk about the photons, we talk about the energy packets. So the energy, it comes in packets, which is it's particles of energy, right? Now it says energy of photon is directly proportional to frequency. From this formula that says energy is equal to Planck's constant times frequency, we therefore see that the energy is directly proportional to frequency. And at the Planck's constant, guys, you get it in the information sheet on the question paper always. You don't have to memorize that. So we know the energy, the light, it has energy, or light is an energy, so it's measured in joules, right? So that's the formula there. And we have another formula here for frequency and wavelength that says V or C is equal to frequency times lambda, which is that one, right? So like this one that says C is equal to frequency times lambda. So if you make frequency as a subject of the formula, you have C divided by lambda, which is that's when it comes from the formula that says a frequency is inversely proportional to wavelength. Do you see the proportionality there? Right, at constant speed they are inversely proportional. And then having this formula, we can say from this formula that says the energy is equal to Planck's constant times frequency. If we don't have frequency, we can substitute it by this. We can say F, instead of F we'll say C divided by what? By lambda. We can calculate the energy by that, right? The electromagnetic spectrum. Electromagnetic spectrum, we have these different waves here: radio waves, TV wave, microwave, infrared, visible light. The visible light, it has the ROY-GB. We have ultraviolet, X-ray, gamma rays. So if you look from radio waves till gamma rays, they're longer, long wavelength, they becoming shorter. Do you see the waves? They becoming shorter, the wavelength, and the frequency is increasing as you start from radio waves till gamma rays. And then the energy is lower there, and the energy is increasing as you go that way. Penetrating ability is increasing as you go that way. So this, it has a lower energy and lower frequency but longer wavelength, right? And the gamma rays here, it has a greater energy, greater frequency, shorter wavelength, right? That's very important, guys, to understand that. That's it about the introduction. Cheers, bye.